So today we're going to talk about this. This is a compound table, sometimes called an XY table, and here I have it mounted to my Home Depot very standard 15-inch drill press. So first off, what is a compound table? Well, very simply, it's the XY portion of the type of table you would see on a mill. There are, on this one, hand wheels that control the X and the Y. So you operate these hand wheels, the table will move forward and backward. There's only one hand wheel for this axis because obviously the column is in the way in the back. This will move it forward and backward. So here we have it on the drill press. Normally, when you're working with things in the drill press, especially if they're wood, normally you just lay it flat, you'd hold it, and the force from the actual press, pressing the drill into the work, would keep it in place. And you would keep the extra part, since the chuck is rotating this way, you'd keep the extra overextension of the piece you're working on this side of the column, so if something did happen and it grabbed and twisted, it would hit the column instead of twisting all the way back around and causing you some discomfort. So normally, when you're working with items on the press, you can either hold it by hand or occasionally you can use something like this. This is just a simple locking, it's like half of a locking plier effectively. You would run this stud through one of the slots in your table. This portion, this is actually just a piece of steel. This rests under it to spread the load on the underside of your table. This would rest on top. You would adjust it for your piece, and then you would clamp it down. You use a couple of these, and it holds the piece in onto the table pretty well on your drill press table. So what's the usage of having this kind of table? Well, this is typically used when machining, which is to say when you're working with metals. So let us say you had a piece of metal, and it wasn't entirely flat. This one is not entirely flat because it's been punched with a transfer punch. Since punches don't actually remove material, they just displace it, there are raised areas where this has been punched. So if you lay it on something that's truly flat, it rocks back and forth ever so slightly. Now, if you didn't have this table, you'd have a fixed table. What would happen potentially is you would put this down and you would clamp it into place. One of two things is going to happen. One, the clamp is going to, however you've clamped it, will pull it to one side of the flat surface. So since your surface on the bottom of your work isn't truly flat, there's effectively a fulcrum, an axis on which it moves, so it can be on this side or this side, in this case of this particular part. So you'll clamp to one of those two sides. Well, if you're pressing down with your drill and cutting on the opposing side, it might move the part back as it drills. So this is a problem. The other thing that might happen is your clamping might actually take a slightly warped piece and pull it flat, pull it with the level of your drill press table. If that's happened, if you had everything lined up and then you clamp it and it distorts the piece, then when you go to drill, you're now in the wrong place. You're not set up correctly anymore. And this is really, really annoying. In this particular case, it's because this has been punched. But unless you are working with metal that has been surface planed or that has been milled previously, almost nothing is flat or square. There's always some type of warp in the surface, especially in the case of extruded material. When it cools, it doesn't cool evenly based on the thickness of the part. In fact, with this, I've had to plane these faces down, independent of their punches. They were not flat because of the different thickness of this material. When it cools, it contracts differently. So when you have these kinds of tables, that you can fix that problem because you can clamp it down first, and that will cause whatever distortion to the piece it's going to cause. Then you can move the clamped piece directly underneath your tool so that it lines up every time. When you clamp things onto these XY tables, they typically will have T-slots. The slots themselves might be different sizes, but you will typically get a set of tools that will look like this. You will have this stair-step pattern on one of these. This is from a standard clamp down kit. You'll have one of these, which is set over here. You will have an actual T slot, or something that goes into this slot, and a stud. Run the stud down, put the nut down into the slot, pull this over, and you'll have one more piece, which is this guy, which also has a matching set of steps on it and a slot in the middle. You put the stud through the slot and you line up about the level you're interested in and mesh the steps together. You then drop your nut on the floor, put it back here, drive your nut down. Now what will happen, this is being held up, of course, by this block. As this nut tightens, depending on where you have it, you will get a levered force that will hold this in place. Obviously, if you're going to set this up for work, you would have at least one on each side. But this will hold it in place. And you can still adjust. You can still turn these wheels, and you can get it lined up exactly under the press how you would like. So, why wouldn't you want to use one of these types of devices? Well, if you're doing something in wood, especially when precision isn't super critical, it's a waste of time. It takes too long to set up all of these bits and pieces to make it worth your while. Also, these tables are heavy, and the table itself will need to be affixed to your actual drill press table. In my particular case, there are 4 bolts, 2 on each side. This particular compound table has slots down both sides. There's 2 bolts on each side. So you'd have to fix it to the table. It also is very heavy. This particular one is about 50 pounds. So when you unlock your plate from the column to raise or lower the table, it's going to be much heavier. And again, just annoying. Now you might be thinking to yourself, what other types of things could I do with this table? Well, this is effectively the table of a mill, so could I mill with it? Well, technically yes, but realistically you shouldn't, for the following reason. First off, your spindle is the only Z adjustment. There's no Z adjustment, up and down adjustment on this table other than your column, but your column has to remain locked so your table doesn't wiggle around, so you can't use that. So in theory, you could set a stop on your press and then you would pull it down and then operate these wheels. This is cumbersome, but the real problem is with your bearings. The bearings that hold your spindle together are designed to resist primarily axial loads. So when you press down, you're going to be taking something like this, a standard drill bit, and it will be pushed into the material. So the load, the reactive force is of course pushing up, and then you have the twisting motion. Lateral motions, this direction and this direction, are not something that the bearings of these drill presses are typically designed to handle. So if you decided I'm going to cut a channel in a piece of work mill style, the spindle is now having to absorb those loads, and the bearings may not be up to the task. If they're not, it will wear that bearing system out, and what you will get is there will be now lateral play in your chuck. So when you go to just do a normal drilling operation, you'll have lateral movement in the spindle, and that would be very, very bad, and in many cases you've effectively destroyed your drill press, which is not good. But if you're just using it for drilling operations and you're working with metal and you've had one too many nasty experiences where it's just too difficult to get the piece clamped down in such a way that it remains lined up with your tooling, then these things are pretty awesome. Now, they do require adjustment. Typically when you get them, especially this particular model, which is a rather cheap one, the gibs will not be set up correctly. So your gibs are effectively plates, adjustable plates inside the frame, which kind of lock down onto the part that moves. If they're too tight, when you turn the wheels, it'll be really, really stiff. If they're too loose, the table will actually have play in it. So if you grab the table and kind of apply force to it, you'll be able to feel that it's moving. Now, what you can do is to adjust it for this particular part of the table, you have 3 screws and 3 nuts. The nuts are just there to lock the screws in. If you unlock the screws, or unlock these nuts, you can adjust the screws. This will adjust that interior plate in and out, increasing or decreasing the grip on the center and on the sides for it. This can move the plates in and grab harder on the table, or move out, allow it to move easier, but potentially introduce play. These will probably need to be adjusted over time, and especially when you first get the table, as soon as you've got it on your in position, it's the first thing you're going to want to check. Because, yeah, when this one came, it was bobbling all over the place. But otherwise, once you've got it set up, and once you have acquired this type of clamping kit, which again is typically a machinist type set of tools, you're good to go. And this makes dealing with drilling on metal pieces much, much nicer.